Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an equation with z, z bar, and the absolute value of z. So we got everything except for the argument, but that's going to come up soon. So anyways, we have this equation z times z bar equals the absolute value of z plus 1, and we're supposed to solve for z. Great. Now what happens if you multiply a complex number by its conjugate? We're going to find out. What does that have to do with absolute value? Because looks like we have three unknowns, but z and z bar are related. Their product is very much related to what we have. So let's get to work. I don't know how many methods I can present, but let's get started. First of all, I want to say there's a general method for these kinds of problems which works most of the time, and that is calling z a plus bi. What's this channel called? A plus bi. Exactly. So now let's go ahead and plug it in. But what is z bar? Z bar is the complex conjugate, remember? So that's a minus bi. You just negate the imaginary part. And the absolute value of z is defined as the square root of a squared plus b squared from the Pythagorean theorem. It's basically the distance from the complex number to the origin, right? And you know that complex numbers can be plotted as a vector, as a point on the plane. You can call it complex plane. The real part and the imaginary part go like that. Okay. And there's an angle theta, which we call the argument, and r is called the modulus, or just the absolute value. Okay. So how do we proceed? Let's substitute everything. Z is a plus bi. And then z bar is a minus bi, and then absolute value of z is just a squared plus b squared square root of that, and then plus 1. Now the rule is when you multiply a complex number by its conjugate, you always get a real number. Remember that? And if you haven't seen complex numbers before, you can go ahead and check out the lecture videos, and I'll talk about all these things in those videos. When you multiply two conjugates, you're going to get sum of two squares, not difference. And that's going to be a squared plus b squared. But notice that we also have the same thing on the right-hand side, sort of, like square rooted. So we can go ahead and do something about it. Like, what can we do? One thing we can do is, which is something you probably wouldn't do, we can just subtract 1 and then square both sides, right? That wouldn't be a good method, would it? But anyways, let's just do it to see what happens. Because our goal is basically to get rid of the radical, right? So this is going to get rid of the radical. Let's go ahead and square the first term. And then minus or plus the square 1 squared. Minus 2 times a squared plus b squared. And that's going to equal a squared plus b squared. Awesome. That popped up again, but we don't have any radicals this time. And now if you go ahead and square this, and then put this term on the right hand side and write this as 3 times a squared plus b squared, you're going to get a quadratic. Now if you go ahead and expand this, again, this is something you probably shouldn't be doing, but if you ever do this, you're going to get a quartic here. And how do you solve this equation? There are two unknowns and a single equation. Can you put everything on the same side, complete the squares, and come up with something meaningful? Yes, this is going to be a little painful. So here's what we should be doing instead. At this point, once you get to this point, you should definitely go for substitution. Because if something repeats in any format, then you should use substitution. For example, here, a squared plus b squared, you see that twice, don't you? So you can call that something. We have two options. Either we're going to call the radical something or it's square. Either way is fine. Let's go ahead and rewrite that. A squared plus b squared is equal to square root of a squared plus b squared plus 1. Okay. And then let's go ahead and call this c. Okay. So from here we get c squared equals c plus 1. And then by putting everything on the same side, we do get a quadratic equation and solve it. Remember, a and b are real numbers, so we're supposed to find a real answer for c, and we do, because a and c, which is not the c here, but anyways, that's a different story. Let's go ahead and solve it. Negative b plus minus the square root of b squared 1 plus 4, which is 5, golden ratio pops up again, right? We just saw that. Divide by 2. There are two values for c. Are we gonna go for both, or should we consider one of them? Let's go ahead and separate these. C sub 1 is gonna be 1 plus root 5 over 2, or c sub 2 is gonna be 1 minus root 5 over 2. So there are two solutions. But the problem with that is, what is c? c is the square root of a squared plus b squared, which is a real number. So c is not complex, even though it's c. It's kind of weird, right? It's not a complex number, it's a real number. Okay? Therefore, and since c is the square root of a squared plus b squared, so let me rewrite it. It can't be 1 minus root 5 over 2. Why? Because 1 minus root 5 over 2 is less than 0, because root 5 is greater than 1. Makes sense? So the square root of a real number cannot be negative. Therefore, we have to go with the first solution, which is 1 plus root 5 over 2. But what does that give us? Just the c. And what is c? c is the square root of a squared plus b squared. So c equals 1 plus root 5 over 2, and that is equal to the absolute value of z. But wait a minute, are we supposed to solve for z? Yes, and we actually did. So the answer, or the solutions, are basically going to be all complex numbers whose absolute value equals 1 plus root 5 over 2. Can you think of some numbers? For example, z can be 1 plus root 5 over 2, or z can be 1 plus root 5 over 2i. It can also be the opposite of this number, or both of these numbers, because they're all going to have the same absolute value. Make sense? So in this case, we're basically finding the absolute value of z, and there are infinitely many solutions. So could we look at this problem from a different angle? Think about it. Like, is there a second method for this? Let's think about it. We have z times z bar equals the absolute value of z plus 1. We could probably use a shortcut here. First of all, let's think about this. Absolute value of z is a real number, right? And z times z bar is also a real number. But that doesn't really help, because if you add 1 to a real number, you're also going to get a real number. Well, another thing we could try is conjugating both sides. Like, what would you get if you conjugated both sides? You would be getting the conjugate of this product, but that is basically the same thing, because that product is going to be switched around. And on the right hand side, we have real number. What is the conjugate of a real number? Like a plus bi. What is the conjugate of a? It's going to be the same as a, because b is 0. Make sense? So I don't think there's any other way to approach this, but if you do know, please let me know. And this brings us to the end of this video. Thank you for watching. Oh, by the way, one thing I could probably mention before we dismiss class is this is actually the absolute value of z squared. So at this point, if you know that formula or the shortcut, you could just call this r, and you're going to get r squared equals r plus 1. And then from here, you can solve for r. And then that's going to give you the same value, which is 1 plus root 5 over 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.